that means you are quiet. Sam, you with me? Okay. Michael? Okay. So, going through a definition. A blank is a line that intersects a circle in exactly blank points. So, a tangent, first blank is tangent. A tangent is a line that intersects a circle in exactly one point. This point is called the point of tangency. All right, what do I mean? So, basically, if you have a line and you have a circle, that line can only touch that circle exactly one time. If I extend this line left forever, right forever, will I ever touch this circle again? Never. That is what a tangent circle looks like. Don't draw this. All right, so I drew this red one up here. In the diagram, how many times is this line shown touching the circle?
Why?
Once. Right now it's shown that it's only touching once. Do you agree? But if I were to extend this line left forever, right forever, would it eventually touch the circle again? Yeah, so is this allowed to be a tangent?
No.
No. If you extend left forever, right forever, it cannot touch the circle again. So this, let's put this here, is not a tangent. That is not a tangent because if you extend that line, it will touch it again. Is this, oh, let's draw it in a different direction. Is this a tangent? No, why? Because if you extend it again, what's going to happen? It's going to touch the circle again. A tangent can only touch how many times? Once. A tangent can only touch once. A tangent segment is the part of a tangent line between the point of contact and a point outside of the circle. So what I just drew here is a tangent segment. If I were to extend this segment into a line, would it ever touch the circle again, other than at that one point? No, and that's what you want to make sure of for tangent segments, that it's not going to touch the circle again. So this is a tangent segment. A tangent line / segment is perpendicular to the radius drawn to the point of contact. What do I mean? I'll show you. Do you all see what I just drew in green? Is that a tangent line? Why no? Yeah, it absolutely is. It's touching the circle only once. If I extend left, right forever, it will never touch again. So what this definition is telling us is anytime a radius touches a tangent, it creates right angles. So when if I have my center point here, if I want to make right angles, I go to the tangent and then that's perpendicular right there. So anytime a radius touches a tangent, what happens? We get right angles. All right, are we ready to do some problems? All right, so here we have AB as tangent to circle C. So here's the thing. I'm creating these diagrams and I'm not completely accurate with my diagrams. So I might draw something that doesn't look tangent, but in the given information, I'll always tell you if it's supposed to be tangent. So right now, the way AB is drawn, it looks like it could potentially touch that circle maybe again, right? It doesn't matter how it's drawn. What matters is how it's given. So if I tell you that AB is tangent, that means that segment AB will never touch that circle again. Does everybody understand? So we go by the given information, not necessarily how it looks. Are we okay with that? Okay, so they're saying AB is tangent to circle C. Then we're told that AC is 17 and AB is 15. We want to first find the radius. Well, do we all agree that CE is a radius? But I have no way of finding what CE is. So I'm going to draw another radius that could potentially help us. Does anybody know where I would draw a radius and why that would help us? Finn?
CB, because it'd be perpendicular.
Good. I would draw CB because AB is tangent and CB is a radius. What happens when a radius touches a tangent? We get right angles. So now this is a triple, something 15, 17. 8, 15, 17. You got it. So it says, what is the radius? The radius is 8. What's the relationship between a radius and a diameter? Anybody know? Good. A radius is half a diameter, so a diameter is double a radius. Wouldn't look, if I were to draw center point as C, I have CB. If I were to draw like CW, wouldn't BW be a diameter? A diameter is always made up of 2 radii. So a diameter is 2 times the radius, which is 16. All right, then we want to find AE. Well, I know AC is 17. How long is EC and Y? How long is EC and Y? Oscar.
8.
Good. How'd you know?
It's a radii.
Good. We know EC is 8 because it's a radius. So to find AE, I'm going to do 17 minus 8, which is 9. Which 8? EC? Okay. Center point C, E is the rim. Isn't that a radius? And we knew BC is a radius, and that was 8. So all the radii of this circle will end up being 8. Yeah, because aren't all radii congruent? All right, number 2. Now we have to draw our own diagram. So it says AB is tangent to circle O at A. So clearly this is circle O. And now I need to draw a tangent line. So I'm going to pick a point and draw a line through it. And now this line is tangent to this circle at what point? A, so that means this point is A. Oh, sorry, did they say this was a segment? I made a line. They said segment AB, sorry. So I'm going like that. And it's tangent at A, which means the other point is B. And then they're telling us AB is 48, so I'm going to label that. And they're telling us OB is 50. So what should I do? You got it. I'm going to create a segment from O to B and label that 50. We want to find the radius. Does anybody have any idea of what I'm going to do here? Tanya? Good. I'm going to draw a radius to the tangent. What happens when a radius touches a tangent? It makes a right angle. Now, don't I have a right triangle? Something 48, 50. That's not a triple, but can I divide this by 2? And when I divide by 2, I'm going to get, I'm going to get 24 and 25, which is a triple. Sam told us that is 7. So go back, multiply by 2, and what is OA? 14. Is OA a radius? Yeah, so OA is 14. What about the diameter? What's the relationship between the diameter and the radius? Sophia. What'd you do? Yeah? You got it. The diameter is double the radius, so we're 2 times 14, which is 28. Oops, what have I done? All right, you guys do the independent by yourself. There we go. We're doing the independent by yourself. All right, so given TP is tangent to circle O at T, so what should you have done? This is O, then I need to draw tangent segment TP. There's my tangent segment, and it's tangent at the point T, so this point has to be T. And then it was TP, so this point is P. The radius is 8, TP is 6. So where am I going to draw that radius? Right to that tangent to make a right angle, and that's 8. Now we want to find OP. This is a triple times 2. Anybody know what this is? 3, 4, 5 times 2, 6, 8, 10. All right, let's do something different. Given AC and BC are tangent to circle D, that means AC is only going to touch circle one time and CB is only going to touch that circle one time, even though it doesn't really look that way. Right? AC is 30. The radius is 16. All right, so we want to find CD. So I'm going to draw CD. Now, when they say the radius is 16, where do you think I'm going to draw this radius to help us? Maya? Yeah, I'm going to go D to A, and that is 16. And then what do I realize I have here? A right triangle. Do we agree? Now, there's no triple 1630 something, but I'm going to divide by 2. And when I divide by 2, I'm going to end up with a 8 and a 15. Is this a triple? 8, 15, 17. Go back and multiply by 2. What do I get? 34. So how long is CD? 34. Now what do they want us to find? BC. Well, to find BC, I'm going to draw DB again. How long is DB and how do you know? Sam? Well, it is 16 because DB's a radius. Yeah, and then that makes a right angle right here. And this ends up being another, basically a congruent triangle to the other one. This is 16 something 34. What was that missing side on the other triangle? 30. So BC is 30. What do you notice about CA and CB? They are congruent. That's not a coincidence, guys. That is not a coincidence. All right, there's a theorem. We won't use this theorem in proofs because I won't give you any proofs, but it will come up in algebra problems. It is called the two-tangent theorem. What does this two-tangent theorem tell us? It tells us if I have a circle and I have two segments that are both tangent to that circle coming from the same point. So do you see how I have PS and PY both tangent to circle O and both coming from point P? So if we have two tangent segments coming from the same point, those two tangents are going to be congruent always. That is what the two tangent theorem tells us. If we have two tangent segments coming from the same point, they will always end up being congruent. All right, conclusion, Px is congruent to Py. All right, let's do some more problems. We have AB and AD are tangent segments. Make a conclusion. If AB and AD are tangent segments, they're both coming from A, therefore they must be congruent. All right, find AB. In order to find AB, I need to solve for x. Sam?
So I was just going to say, aren't you going to do 3x plus 10 equals 6?
You got it. 3x plus 10 equals 7x minus 6. We're going to have 16 equals 4x. X will equal 4. So now we plug in. AB will equal 3 times 4 plus 10, which is 22 units long. All right, we learned this word before. Concentric circles are two or more coplanar circles with the same what?
Center point.
Good, with the same center point. All right, so let's think how strategically we can plot this given information. So it says concentric circles with radii 5 and 8. Clearly, the smaller circle will have a radius of 5 and the larger circle will have a radius of 8. Doesn't that make sense? All right, BC is tangent to the inner circle at D. All right, let's start off with the smaller radius. So I'm going to go to my smaller radius, the inner circle. Where do you think I'm going to draw that radius of 5? Looking at this diagram completely, knowing that BC is tangent at point D. Where do you think I'm going to draw that radius to help me? Julia? AD, you got it. So why am I doing that? Because it makes a right angle, and it's always about right triangles, really, but this gets us at least a right angle. So now, since it's always about triangles, mostly right triangles, where do you think I'm going to draw the bigger radius now? Where do you think I'm going to draw the radius of the larger circle, that 8-unit radius? Simon?
AB and AC.
You got it. I'm going to go AB. That is 8. Or you could do AC. That is also 8. Now I'm going to use one of these triangles. Doesn't matter which one you chose. So if you drew AB, you're going to use that triangle. If you drew AC, you're going to use the other triangle. If you drew both like I did, you get to choose which triangle you want. All right, is this a triple? 5 something 8.
Yes. No.
No.
No, it stinks when it's not a triple. What do we have to do? Pythagorean theorem. I'm going to call B dx. Who can set up this Pythagorean theorem for me? Finn?
X squared plus 5 squared equals 8 squared.
You got it. X squared plus 25 equals 64. Then we're going to have x squared, subtract that 25. So we're going to have x squared equals 49, thanks. 39, you're right. Square root both sides, x will equal, technically plus or minus root 39, but could a length ever be negative?
No.
So it's just root 39. So then BD is root 39. Uh-oh, don't die.
Oh, no.
Oh, no. Whew. Okay, so we know BD is root 39. What does that mean for DC? It is also Root 39. So how long is BC? 2 root 39. Tanya, you made me so happy. 2 root 39. All right, let's do another one like that. Just a little bit different. All right, concentric circles with point A as the center. The smaller circle, y'all all right? All right, the smaller circle has a radius of 21. BD is tangent to the inner circle at C, and BD equals 56 units. So BD is 56. Do you guys remember from, I think it was the last lesson, or maybe the lesson before that, what happens when a radius intersects a chord? What does it do to it? Well, if it's perpendicular, which it is, it bisects it, right? So this 56 is going to get split into 28 and 28. The smaller circle has a radius of 21, so we know AC is 21. Find the radius of the larger circle. I'm going to go ahead and I'm going to draw BA. You could have also drawn AD. It doesn't matter. Hey, so I'm now using this triangle. I'll redraw this triangle so it's not as blurry. We have BCA. We have 21, 28. I'm going to divide this triangle by 7. And when I divide this triangle by 7, don't I get a 3 and a 4? What's the triple? 3, 4, 5. So go multiply back. What am I going to get? 35. That means AB is 35. So when they say, what is the radius of the larger circle? You tell me, what's the radius of the larger circle? 35. So is AE a radius of the larger circle? AE? Yeah, A to E is a radius of the larger circle, so that's 35. We know AC is 21. How long is CE going to be? Mia?
35 minus 20.
You got it, 35 minus 21, which is 14. All right. I think this is our last part of today, common tangents. A common tangent is a line tangent to two circles. So if you look at this, we have AB is tangent to the first circle and it's tangent to the second circle. AB over here again is tangent to the first circle and it's tangent to the second circle. So that's what a common tangent is, when one tangent line or segment is tangent to two different circles. So there are steps to find a common tangent. You must memorize these steps. You want to memorize these steps. We'll read through the steps and then I will demonstrate it for you. Draw the segments joining the centers. Draw the radii to the points of contact. Label all given information. Now this is huge. Everybody put a star on the third step because this is what everybody messes up on. Through the center of the smaller circle, it does matter. You cannot choose the larger circle. Through the center of the smaller circle, draw a line parallel to the common tangent. Okay, use the triples or the Pythagorean theorem. Now, none of this means anything to you until we do a problem. Are we ready? All right. So, given AB is 25, AD is 10, BC is 17. First step, draw a segment joining the centers. So what am I going to do? I'm going to draw a segment from A to B. Try this again. I think I'm better off freehanding it.
Can you just hold shift?
I don't know how to do that. Okay, so now what's the next step? Draw the radii to the point of contact. What does that mean? That means I'm going to go to circle A and I'm going to draw a radius. They're saying the radius to the point of contact. What is the point of contact? Where the tangent line meets the circle. So I'm going to draw a radius from A to D. How long is that? 10. Then I'm going to draw a radius from the bigger circle to the point of contact, so from B to C. Now this you want to label like this. The larger one you want to put sort of like a bracket to label it. That's 17. Oh, and they told us something else. What did they tell us? They told us AB is 25. All right, are you ready for the step everybody messes up on? Go to the center of the smaller circle. What is the center of the smaller circle? What point? Point A. From the center of the smaller circle, draw a line parallel to the common tangent. So from A, I'm going to draw a line parallel to DC. I'll call this point W. I've just created two shapes. Why is this? Uh-oh. Oh no. Where'd it go? All right, I've just created two shapes. What is this shape, do you think? Take a guess.
Rectangle.
It is a rectangle because when a radius touches a tangent, right angles. When a radius touches a tangent, right angles, right? This is absolutely a rectangle. And if it's a rectangle, aren't there more right angles over here? All right, what is this shape?
Right triangle.
A right triangle. Excellent, excellent, excellent. All right, so now we want to find the common external tangent. Which segment is the common external tangent that we're trying to find? Which segment in the diagram? Which one are we trying to find?
Oh, wait.
That's the common external tangent. Michael, what'd you say? DC. Nice. External tangent. External means outside or inside?
Outside.
Outside. So outside and tangent to both circles. Isn't that DC? That's what we're trying to find, the common external tangent. But we're not going to be able to find it right off the bat right now. We got to do a little bit of manipulation. Do you all see DAWC, this rectangle? If the left side is 10, the right side is also 10. What does that mean for WB? It is 7. Now look at the triangle. 7 something 25. What's that triple? 24. If AW is 24, which other segment is 24? DCY. Why is DC 24?
Opposite sides are congruent.
In a rectangle, opposite sides are congruent. So isn't DC the common tangent? So it is 24 units long. Should we try another one? Anybody still copying? I'm not really getting much feedback. You're not, okay. So radius of circle P is 8, radius of circle O is 18. Find the common external tangent. Okay, how about I ask this first this time, since we were a little confused last time. What am I trying to find? Which segment that's drawn here? AB, correct. We want to find AB. So first step, draw a segment connecting the centers. So I'm drawing O to P. Second step, draw the radii to the points of contact. What does that mean when I say draw the radii to the points of contact? Draw a radius from O to what? A. That makes a right angle, right? And then I'm going to draw a radius from P to B, that makes a right angle. And then the radius of circle P is 8. The radius of circle O is 18. Remember for the bigger radius how I mark it. All right, the step everybody forgets. Center of the smaller circle. Which one's the smaller circle? P. What am I going to do? Draw a line parallel to the common tangent. I'll call this point W.
Should we mark it?
You don't have to if you don't want to.
I marked it.
So then, once again, what do I have? I have a rectangle and I have a
Right triangle.
right triangle. All right, we know in a rectangle, opposite sides are congruent. So if BP is 8, AW is 8. What does that mean for WO? I can't do the Pythagorean theorem because there's no triple, right? Because I only have one side. Does anybody know how I can find the total length of OP since they didn't give it to me? Anybody know how I can find the length of OP? Oscar?
Add the radii of the two circles.
Yay, Oscar, you made me so proud. Okay, look, right here from this pink segment right here, isn't that a radius of circle O? So that's 18. Look at this green segment right here. Isn't that the radius of circle P? So that is 8, which means OP has to be 26. I'm going to redraw this triangle now. We have WPO. We have 10 and 26. I'm going to divide this triangle by 2. When I divide the triangle by 2, I'm left with a 5 and 13. What's the triple? Go back, multiply by 2. The missing side is 24. If WP is 24, which other one is 24? AB, and that's what we want to find. You still copying? Can I keep going?
One more.
I'm going to do number 3 with you. So I'm going to skip number 10 and go to number 3. You like how I numbered that? Okay, so now this one's a little bit sneakier. This is not an internal tangent. This is not an external tangent. This is an internal tangent. So let's label this AB. We still want to find the common internal tangent, so we want to find AB. The centers of the two circles are 15 feet apart. If the radius of the larger circle is 8 feet and the radius of the smaller circle is 4 feet, find the length of the common internal tangent, which is AB that we just labeled. All right, let's call this circle O. Let's call this circle P. First step, draw a segment connecting the two centers. And we were told that the centers of the two circles are 15 feet apart. So what does that mean for OP? I'm just going to write it to the side because I really have no idea how this diagram is going to look. So I just put OP is 15 and I'll label that in the diagram later because I'm not sure where I want to place it just yet. All right, then what do? We draw the radii to the points of contact. Well, where do I draw a radius? From O to? I heard it. A, isn't that a right angle? And this is the smaller circle, so this is 4, right? And then I'm going to draw a radius from P to B, so this is the larger radius of 8. All right, are we ready to mess things up? All right, from the center of the smaller circle, always the smaller one. Which one's the smaller circle? O. Isn't AB the common tangent?
Mm-hmm.
Draw a line parallel to the common tangent. So I'm just drawing it like that. See, I've messed things up. All right. Yeah, that's what we're doing.
So we still mess things up, but not like we're gonna like actually mess.
No. Like I've made things more complicated. That's what I mean when I said I messed things up. All right, so now I have this open gap here. Do you guys see this open gap? What do you think I'm going to tell you to do? Close it up. Sorry.
So wait, this is gonna be on the test.
I mean, I'm showing it to you. It's fair game. All right, so now things are a little bit different. Let's call this endpoint W here, just so I have it. Do you all see AOWB? That's a rectangle. That is our rectangle. Right, that is our rectangle. So if AO is 4, BW is also 4. How long is PW then? 12. Now I need to use the right triangle. The right triangle I'm going to be using, I'm outlining now in green. Do you see this triangle? All right. I'm going to use this triangle. OPW. W is a right angle. PW is 12. And didn't we already know about OP? How long is OP? 15. This is a triple times 3. 3, 4, 5, so it is 9. OW is 9. If OW is 9, which other segment is 9?
AB.
AB. Isn't that what we wanted to find? Should we call it a day?
Yes.
All right, your homework's a worksheet. Is it, if you scroll down, do you guys see it? That's your homework. All right, we are done for today.